So, hey everybody. It's nice and rainy here in Knoxville, and it's very quiet in my building and a little chilly. So we'll just go with it, and you may see me shivering. That's not your screen, that's me. Anyway, so we're here for the communication workshop. I can't believe it's been a whole year since we initially met via Zoom. But last year we talked a lot about just messaging and knowing your audience. And so today we're going to talk a lot more about how to test your messages and how to know if your campaign has been successful, how to measure the success of your campaign. So first I'm going to turn it over to Corey, and he's going to talk about mosquito egg updates or whatever needs to be talked about regarding mosquitoes. And then I will talk about first on message construction, and then the second set of talks will be on, the second presentation will be on evaluating your message success, your campaign success. And then we have our guest, Mike Doyle, who's going to be our lunch and learn speaker. And then Josh will talk to you about what? About your lesson plans and stuff like that. I'm sorry, my head just went completely blank, which happens a lot these days. Okay, so that's kind of the plan, and I'll be making you do some breakout sessions to see if you can come up with tactics of evaluating your messages when we get to that point. So are we ready then, everybody? Okay, Corey, I'm turning it over to you. Take as long as you want.
Okay, I do not have screen sharing. Host disabled screen sharing is my prompt. Oh, there
Try
it is.
again. That was amateur
Okay.
hour over here.
Let's see if I can. Okay, do you see PowerPoint? Awesome. Okay, so I don't have a very long presentation. I don't have a lot of new information that I didn't share in our last workshop, but I will update us on where I'm at with our megabytes work from 2020 and some plans that I have to do some more work this summer that will hopefully turn into some more opportunities for us in future megabytes cohorts. So the big thing I've been working on is screening these mosquitoes that we raised for lacrosse virus. And so this has been a lot of lab work, like the kind of lab work where I get to wear my new coat. We bought me one of these white lab coats and some safety goggles, because what I've been doing is taking all the mosquitoes that you all collected and that I collected as eggs and that we raised up to adulthood, and I've been identifying them under the microscope so that we could see what species and sex they were, but also putting them into these tubes so that we could begin to extract RNA from the mosquitoes. And RNA is like our virus version of DNA, and when you extract the RNA from mosquitoes, you can screen it to see if any of that RNA is a virus that you're interested in. So that video you're seeing in the middle, that's this cool machine we have. It's called the Kaya Cube, and it does a lot of that process for us. My role in this is really moving mosquitoes into tubes, putting this chemical in there that inactivates all these natural things that sort of degrade RNA and DNA. I shake them up and literally just destroy the mosquitoes, like get them all mashed up. And then I move the product into this machine and it does tons of pipetting and cool stuff to really purify that RNA. And then I take that purified RNA product and do quantitative PCR on it. And if you hadn't heard of PCR before, you probably have now because of the pandemic. People are using this all the time to determine if someone has COVID. And the idea is that you take a sample and you amplify, you put in like some specific DNA that can target a certain gene, and in the case of COVID it would be a COVID gene. In this case it's lacrosse, and it amplifies it a whole bunch, and just clones that gene over and over so that this machine can see through some fluorescence because of a chemical in there if that target gene you're trying to find is amplifying. And if it is, then you'll see the result on a graph like this. So where those lines are going up, it's showing fluorescence. And so I've been testing all our mosquitoes for lacrosse in this way and seeing if the lacrosse virus will amplify in the RNA that I extracted from the mosquitoes. And I've screened a bunch. I screened all the Aedes triseriatus that we got, and I screened a lot of the Aedes albopictus. I did pools where we had at least 10 mosquitoes for albopictus because some of the pools had very few, and this process is kind of expensive, so I tried to limit it to ones that were more likely to have lacrosse virus. And I've screened about 1,300 pools. So if you remember, a pool is like it's one species and one sex from that species from one trap for that week. So I've got pools for all of us for every week for every trap, and I have a little over 2,000 pools total, and I've screened about 1,300 of those. And I've not been finding lacrosse really at all. I had one positive pool, and I've tried to replicate that over and over, and I can't get it to be lacrosse positive again. And so it seems like it's been a false positive. But all these screening results are kind of turning into suggesting that we didn't have a lacrosse virus in these mosquitoes that we collected, which could be really good news if you're looking at it from the public health perspective. From the just like research interest perspective, I guess that it's not as exciting because we didn't find like a place where there's like a lacrosse hotspot. But considering that we're looking at your schools here, this is probably a good thing. Um, what's unclear is, does this truly mean that there's no lacrosse in that area, or does it just mean that we missed it with our method here? Because if you remember, we're collecting just eggs, and so we're only relying on an infected female mosquito passing the virus on to her eggs in this method. So we're not capturing the potential of a mosquito to bite like a squirrel or a chipmunk out in nature and become infected that way. And really, research wise, I would say it's unclear for lacrosse. I don't think we know for sure what is the main driver of lacrosse infections in humans. Is it that transovarial transmission from the mother mosquito to the eggs, or is it the biting of a mammal in nature that causes this to spread into humans? It's not really sure, but anyway, we're not finding a lot of lacrosse or any in these eggs, and that's kind of where we're at. So I'm getting ready to move forward as it's becoming warmer with my summer research plans. And what I'm doing this time, instead of taking like 30 some sites to try to match what the megabytes participants were doing, which was a big goal we had for 2020, I'm selecting just a few of those sites, about 10 of them, based on the results that I had from last year. And I'm going to do more in-depth mosquito surveys at those fewer sites. Um, Particularly, I'm choosing some sites that had a lot of Aedes tricereatus, the tree hole mosquito, some sites that had a lot of albopictus, the tiger mosquito, and then I'm picking some sites that had kind of an intermediate abundance of both of those, where there was kind of a similar amount of both species. And what I'm going to do is add adult mosquito traps along with these oviposition cups we've been using, because I want to compare the wing lengths of the mosquitoes we capture among those different sites. And the reason for this is that there is some research that came out that was measuring competition between the tiger mosquito and the tree hole mosquito. And it found this weird result where if there was a lot of a tiger mosquito in a cup where the larvae, like the larvae of both species, were developing, if there were more of the tiger mosquitoes and fewer of the tree hole mosquitoes, most of the tree hole mosquitoes would die and not survive. But the ones that did survive were much larger and more likely to be able to take a blood meal and to become infected with lacrosse virus. And this is different than other results for other competition experiments with different species. Normally, you'd think that if the species is having a hard time surviving, they come out smaller and in some cases are less dangerous. But in this situation, the tree hole mosquito came out larger and maybe more dangerous from a lacrosse perspective. And so what I'm interested in doing is measuring these wing lengths at different sites with different relative abundances of the species and seeing if we can see that difference that they found in the laboratory in a natural setting. I also want to do some things that might be really relevant to the megabytes program specifically. One thing I want to do is implement this newer adult trap. It's really new to me. It's not as new to mosquito world, but it's called the Gravid 80s trap. And it is similar in concept to the oviposition cups we've been using. It's a big plastic bucket type thing. You're seeing the picture on the bottom left. And what you do is add water in the bottom, like you do for the oviposition cups. You add some sort of thing to kill the mosquitoes into that clear plastic part. You can use canola oil, that will work. You can add sticky cards, kind of like one of those sticky fly traps you could get at Lowe's or Walmart or something. Or you can add an insecticide. But the idea is that the
clear about what doing drugs does.
Sorry, that was me.
The idea is that the mosquitoes will fly into this trap to lay eggs as they do for our oviposition cups. But in this case, we actually get to kill and capture the adult mosquito that's laying the eggs. instead of just getting the eggs. And so one thing I'm interested in knowing is, are the results of these traps similar to what we get for the oviposition cups? In theory, they should be, because we're getting mosquitoes to come lay their eggs in our oviposition cups. And in this trap, we're getting the mosquitoes to come lay eggs, but instead we're just capturing the adult females. And why this might be important is that for our megabytes program, it's a whole lot of labor to hatch and raise all the mosquitoes that we're getting with the oviposition cups. And so if we wanted to have this sort of program be replicated in other areas, or if other universities wanted to add their own kind of megabytes version, but they didn't have the staff or the space to hatch a ton of mosquito eggs, this sort of thing might be a time saver where we could capture adult mosquitoes instead of eggs. And I've got this bullet called entomology, and that's because I have found there's a program in Australia doing something kind of like megabytes, but it's with more the general public instead of just schools. And they're using these traps, and what they're having the participants do is just take pictures of their collections. And that's this picture in the middle, a picture of some mosquitoes, is from that publication, where those participants just took pictures of their collections, and entomologists are able to identify the mosquitoes based on the photos. And I think that, if these traps work, if in my summer research, if these seem like they're effective, then we might get to pilot that idea with some of our megabytes participants in 2021. The last thing is using this honey card method to survey for lacrosse virus. So I said that I've been testing all these mosquito pools for lacrosse, which is like 1,300 pools. There's this new idea that exploits the sugar feeding behavior of mosquitoes to survey for viruses. So mosquitoes, they don't only take blood meals, they also feed on sugar to survive. And you can take these special cards that preserve DNA and RNA, and you can coat them with honey, and the mosquitoes will feed on those cards. And while they're doing so, a little bit of saliva will come out of their mouths. This is how they spread viruses normally. When they're biting someone, some virus comes out of their proboscis and into the body that they're biting. The same idea when they're sugar feeding, they'll expel some saliva, and that will get preserved on these cards, and you can extract RNA from the card and test the card for the presence of the virus. And so what I'm thinking is that when we're hatching 1,000 eggs from one of your oviposition cups, we have those mosquitoes become adults in one of these plastic containers, and we can let them feed on the honey coated card. And then instead of testing every single mosquito that emerges, we can just test the card and see if any of these cards test positive for lacrosse virus, and then use that to determine which cups potentially had the virus, and then target those to trap or to survey all the mosquitoes. And so that's something I'm hoping to test out this summer. It would be more efficient if I could find a place where I knew lacrosse was being transmitted so that I could know that some of the mosquitoes are going to come out and be infected. But I'm still trying to come up with ways to make this work. So those are some of my plans that will hopefully be helpful for megabytes in the future. That's all I have for this presentation, though. So that did not take 30 minutes as scheduled, but hopefully that was not too boring or rambly. I didn't spend a lot of time preparing for this, honestly.
So Corey, we actually have several questions in the chat. I'm going to run back
cool.
through them. David, down near Chattanooga, is interested if you know where the false positive was.
Yeah, so the way that I'm doing these PCRs is that I'm, in order to save money, I've been taking pools and pooling them together. So if we had 3 different schools that had an oviposition cup, I might have those 3 schools in one PCR pool. And then if that becomes positive, then I test all 3 of those separately. And I'm doing this because we have a lot of mosquitoes and we expect few of them to be positive. And so I had one positive PCR pool that contained some RNA from one of my mosquito sites, and 2 schools. But we expected it was probably from my site because that particular site happens to be in a neighborhood where a child had become sick with lacrosse encephalitis. And so we think that it's spread there. But there were also 2 schools that were possibly in the mix, but I haven't been able to replicate that positive result when I've been testing them individually. So I don't know what that's about.
And then Mike was asking, when you were talking about this idea of mosquitoes that are more dangerous. I think this was when you were talking about based off the size. Is that because of higher potential viral, and I think the right word is titer, or a longer flight distance, longer life, or do you have any ideas on that?
It's a few things, and I've seen papers that kind of suggested the other way around, that smaller mosquitoes would be more dangerous. But in this case, they were considering the larger Aedes triceriatus to be more dangerous because, for one thing, the larger mosquitoes are more likely to successfully bite something. So I guess that generally we're thinking bigger mosquitoes are more fit, if you will imagine that. And so they're more capable of flying, they're more capable of identifying a host and then accessing it. They take a larger blood meal, so they consume more blood, so that might help them become more infected. And maybe most importantly is that the larger mosquitoes tend to survive longer. And so the idea is that this mosquito will live long enough to bite one thing, and perhaps that first thing that it bites is like an infected squirrel, and then the mosquito will become infected and live long enough to take a second blood meal later. And it's really that second time that they bite that would be the time that they get to spread the virus, assuming that they weren't infected when they emerged in the first place. And so those are the things that sort of contribute, at least in theory, to making them more dangerous. I think that a lot of that evidence comes from these laboratory studies, though, and not from really good field research to determine what drives the most dangerous mosquito, especially in lacrosse. It's a little bit different in maybe in some other systems where this has been studied more so. But those are the ideas for that.
And Corey, just because I'm totally curious, how does a graduate student go about measuring wing length of mosquitoes? Because that seems like they'd be really small and really delicate.
It's not as hard as you'd think. I did this for my master's research, actually. You can the mosquitoes themselves are pretty delicate, but the wings seem to be a bit tougher. And so under the microscope, it's not that hard to just remove one of the wings. And we have these cameras that go in our microscopes, and the software allows you to just trace a line. And so you can draw the line on the wing and get a measurement. Once you get some practice at it, it doesn't take too long. I just remove the wings and put them on some double-sided tape that's on like a microscope slide, and then I measure it under that microscope with the camera. And I think that I even had an undergraduate student with me that I was mentoring last time, and she was able to pick it up. So it's not as, it sounds more impressive than it really is.
I just can't believe I have learned so much about mosquitoes and mosquito life cycles and mosquito anatomy. This is a point in my life that I never thought this would be something so important to me.
Welcome to the club.
Does anybody else have any questions or comments they want to share with Corey? I did have one question about sharing the video with the students. This whole thing is public. All the videos are going to get posted online. So I just want to let y'all know that there's no reason why you shouldn't be able to share these things. I'll confirm all that with Becky, but that's my expectation is you'll be able to share everything. And then Corey, I guess the other thing we got to do is we got to make sure we share the TNCHC presentation with the folks too. And that way, if it's something that they need to give to an audience where it sort of condenses the whole program into a very short part, that might be useful. So I'll make sure we share that as well.
Hey, my students had a question. When we were doing our analysis on the data, some of them said, hey, I've got mosquitoes born, but no eggs. And they were doing an egg mosquito comparison.
Yeah, that definitely happened. Obviously there were eggs, but I think that what happened in those cases is that there weren't a lot of eggs and I missed them. Because I was doing the counting of all the mosquito eggs, and in some cases I think that maybe I failed to adequately look at both sides of the mosquito paper, or they were just dirty and I didn't find the eggs. But in those cases, even when we thought we found 0 eggs, we went ahead and put them in water just in case. And there were definitely some situations where I had counted 0 eggs and then some eggs hatched. And so that's how in the data set you could have 0 eggs but have some adults, because I failed to find the eggs when I counted them. So that would explain that. It's most likely not a data entry error. It was more of just a me me
In
not
there.
finding eggs error.
It happens. How many eggs were you counting again? How many thousands?
I counted a lot of eggs. I don't remember what the number is right now. It was a lot of time doing one by
You're
one egg
You're
counting.
a better man than me.